All right. This video is about multiplying radicals, and we'll have one about dividing radicals after this one is over. Um, a lot of students will tell you that adding and subtracting radicals can be more work than multiplying, and I'm always hesitant to say that it's easier. Um, but it seems like students might get it a little bit faster, and I don't think it always necessarily means that that's easier. So let's take a look at these questions here. Um, we're going to make use of two things. Number one is the order that you multiply doesn't matter. 2 times 3 is the same as 3 times 2, right? So you can multiply in any order that you want. We're also going to make use of that property. Remember that property that when we were simplifying, we would separate them as two different radicals? Well, now we can put them back together too and then simplify. Okay, so again, the direction is to multiply and simplify in these questions. So here's number one. First thing I'm going to do is I'm going to change the order that I'm multiplying around. Now, this is still all multiplication, and I just put the numbers without radicals together and the numbers with radicals together. 5 times 6 is 30. Square root of 2 times the square root of 5. This is where I'm going to put them back together as the square root of 2 times 5. And 2 times 5 is 10. So 30 root 10 is what I have right now. And now you should always check when you do that, because sometimes when you multiply, you'll create a radical that can be simplified. 1 goes into 10, 4 doesn't, 9 doesn't, we're done. This is the final answer. And if we could simplify, we would. Here's the next one. 3 times 4 root 3. Okay, well, same thing. Let's multiply in this order. 3 times 4 times square root of 3. 3 times 4 is 12. 12 square root of 3. No perfect squares inside 3, so we're done right there. A lot of students will say at this point, Freely, can't you take this number right here and put it inside the radical? Well, yeah, you can, but then you have to simplify it, and you get right back to this point right here. Okay, so keep in mind what we do with adding and subtracting. Once this has no more perfect squares, you're done. Don't make it any more complicated than that. All right, now square root of 11 times square root of 11. This is always an interesting one, and I want you to watch. I'm going to put them back together underneath the radical. There's no numbers other than 1 out in front. So square root of 11 times 11, which is the square root of 121. And the square root of 121 is plain old 11. Notice this becomes this. Now, you're going to use that. In fact, we're going to use that when we get to division for something that's very important. But the square root of a number times the square root of that same number is just that number. So here's a ridiculous one. Square root of 1,234 times the square root of 1,234 is 1,234. I did not actually multiply 1,234 times 1,234 like I did right here. I just know that the results give me that number that's underneath the radical sign. That's an interesting one that you're going to run into. Here's number 4. I'm going to put it in the order that I want. Non-radicals times radicals. 5 times 5 is 25. And here we are running into what we just looked at a second ago. Square root of 3 times square root of 3. Well, if you put it underneath, that's the square root of 9. Square root of 9 is just plain old 3. That was pretty quick, but I took advantage of what I learned from this question right here. So 25 times 3 is just 75. Okay, next one. 5 root 3 squared means 5 root 3 times 5 root 3. Look familiar? It's the same one as before. Okay, so 75. Okay, I just wanted to show you that you can write this question as that number squared. Okay, let's look at the last one. Square root of 10 times square root of 2. I can put them underneath the radical, which gives me the square root of 20. Now I got a lot of students that will say, hey, I'm done. Well, did you check? When you multiply, sometimes you'll enter in perfect squares that need to be factored. 4 goes into 20. So I can write this as the square root of 4 times 5, which is the square root of 4 times the square root of 5, and the square root of 4 is 2 root 5. Please remember to always check the radical or the radicand and the number underneath the radical sign to see if you can factor it before you say that you are done.